Hey everybody, Dr. A here. In this video, we are going to be exploring an example problem of using point-slope formula to calculate an unknown value. Okay, so let's get started with our given information. So in this problem, we want to use point-slope formula to compute the value of y in the data table. So we're given this data table where, draw it a little bit better, where we have x values and y values. I'm using capital X and capital Y here. And so our x values are going to have, we're going to have an x value of 1 that corresponds with a y value of 2. And then we're also going to have an x value of 5 that corresponds with a y value of 4. And the unknown y value that we're looking for is going to be lowercase y, corresponding to a known x value of 3. Okay, so in this data table, we have this column of x values, which you can think of these as independent variable values. And then we have this column of y values, which you can think of them as dependent variable values. And so we have two known ordered pairs. We have a point or an ordered pair of 1, 2, and then we have another known point or ordered pair of 5, 4. And what we are being asked to do is use the point slope formula to compute this unknown value of y here that corresponds with an x value of 3. And if you notice, this x value of 3 is in between the known x values of 1 and 5, where we know some points. Okay, so let's go ahead and get started. We're going to write solution here. And so the first thing we need to remember is, what is point slope formula? Well, point slope formula has the form of y minus y1 equals m times x minus x1, where m is the slope of a linear equation that we are utilizing or building, and then x1 comma y1 is a known point. Now, what's great about this is x1 comma y1 is a known point, any known point along the line that is generated by this equation. Okay, so referring to our data table, when we perform the calculations here in a minute, we can use 1, 2 or 5, 4 as our known point. Okay, so I'm going to use one of them, and I'm going to encourage you on your own to use the other one and see that you get the same end result for this red letter y here, this red value of y. Okay, so let's go ahead and get started. The first thing we can do is we can go ahead and figure out what this slope m is. Okay, so we are going to establish a linear relation through the two known points by computing a slope m through them. Okay, so let's do that. Let's say that m is going to be equal to what? Well, if you remember from Algebra 1, slope is the change in y over a change in x values. Okay, so and being a little bit more particular about how we define that, it's the change in dependent variable values divided by the change in independent variable values. So we can say delta y over delta x equals what? Well, let's look at the delta y first. It's a change in values using the known points. So we can say delta y is going to be 4 minus 2. All right, 4 minus 2. and then divided by delta x, which is 5 minus 1, okay? 5 minus 1. And so we can kind of collapse that, and what do we get? Well, 4 minus 2 is 2, 5 minus 1 is 4, so we see that this is clearly 1/2. The slope using these two known data points is 1/2, okay? Throwing a linear relationship between the two data points that we know. So we can put a little check mark here. We know what m is. Now we use either of the known points as x1 comma y1. Okay, so we can use either known point as x1 comma y1. Okay, now I'm going to use 1 comma 2. Okay, I'm going to use this known point 1 comma 2 as my x1 and y1. Again, I suggest on your own time use 5 comma 4, and you'll see you get the same result for this unknown red y value. Okay, so using x1 comma y1 as your known 1 comma 2, we're going to have the following. We'll have y minus y1, which is this 2, okay, equals your slope, which is 1/2, times x minus x1, which we're using the value of 1 there. Okay, so this 1 is this x sub 1 here. Now we can do a little bit of rearranging, and we can establish this as a linear equation. If you want, you can rearrange this and see that this is y equals 1/2 x minus 1/2 plus 2, okay? So all I did was I distributed this 1/2 to the x and the minus 1, and then I added 2 to the other side of the equation, and then we'll get y equals 1/2 x, and then of course 2 minus 1/2 is 1.5, so we can write that as plus 3/2. So this is a nice governing linear equation using the two known points. Now what we want is we want the value of y when x equals 3, okay? So think about that. We want y when x equals 3. So all we need to do now is substitute x equals 3 into our equation that we built through those two known points. And so we can say y equals 1/2 times 3 plus 3/2, okay? And so we, of course, get y equals 3/2 plus 3/2, and of course, this is y equals 3. So finally, y equals 3 is the value of that we were looking for. Now, those of you who saw the video, my video on explaining linear interpolation, if you notice the example, the first linear interpolation example in the linear interpolation intro video was this same data set, and in that video we used linear interpolation to get the same value of y equals 3. So I suggest, for your own knowledge, go back and watch that linear interpolation video with the first example, because we use the same values here, and in that video we used linear interpolation to get y equals 3, and in this video, of course, we use point slope formula to build a linear relationship, and then we ended up getting the same value for y that we got in the previous video, which makes perfect sense because linear interpolation will get you the same kind of results that point slope formula manipulations will get you, and it also turns out it'll get you the same results that direct proportionality gets you to, and similar triangles. So that's going to conclude this video.